Welcome, Hornets, and thank you for joining me today. Today I'm going to be taking a look at the Honors Pre-Calculus Pre-Chapter 4 test. This is working with our basic conversions and beginning materials for trigonometry. So things that we'll be looking at in this video are how do we convert from degrees to radians and radians to degrees, find an arc length or the area of a sector, how to draw an angle in standard position, be it in radian or degree, and then how to evaluate our sine functions in this video. All right, so let's go ahead and begin. We're going to start with conversion. And you'll notice on this page, you'll see that I'm going to convert 72 degrees and 225 degrees. When you're trying to convert, you want to multiply by pi divided by 180. And your goal, you'll notice the degree units will cancel. Now our goal is to slowly reduce this by dividing by 9 or by 3 or by something that goes into 72. Now we know that 72 is made by 8 times 9 and 180 is made by 9 times 20. So I'm going to remove a 9 first, leaving me with an 8 and a 20. I'm now going to divide in half, leaving me with a 4, a 10, and divide again in half, leaving me with a 2 and a 5. I can now put it together as 2 pi over 5, and this is now in radians. If you wish, put rad. Second one, 225 degrees. Now, if you already know it's a 45-degree reference angle in the third quadrant, you can go ahead and simply convert it into the pi over 4, and in the third quadrant, it would be 5 pi over 4. So that's what we expect. Let's go ahead and do it the longer way. 225 over 1 times pi over 180. So I'm going to start by dividing by 5. And when I divide by 5, I'm going to have 45. And let's just get rid of these units. And then I'm going to divide by 5. And that's going to end up giving me 20, and I get a 26. Hang on, let's double check that again. Goes in, I'm going to check that one more time. So I'm going to take my 180 and I'm going to quickly divide by 5 just to make sure. 5 is going to go in 30. That's what I thought. And then I have 36. So 36. Now I know that let's see, 9 times 5 would give me 45. I'm going to break this down and divide by 9. And I'm going to divide by 9. It no longer will reduce, and I put it back together as 5 pi over 4 rad. Let's now go to our conversion of radians into degrees. Be aware that should be degrees right here. It's a typo that I made on the pretest. Hopefully that didn't hurt anybody. We're now going to multiply 8 pi over 9 by 180 over pi. This will get rid of the pi's. I can reduce the 9 and the 180 into 20 times 8, and that gives me 160 degrees. Taking 11 pi over 10 and multiplying by 180 divided by pi, pi will reduce. 10 will reduce into the 180 to be 18, and I now have 18 times 11. Multiplying, I get 118, and then I get 18 again, and I get 198. So my answer is 198 degrees. Please remember to include your units when you're doing this. That will be an issue if you don't. Number 3. Number 3 is working with arc length, and arc length is S equals r theta. So I'm going to take my r, which is 5, and I'm going to multiply it by pi over 4, and I want exact values in terms of pi, So I get 5 pi over 4, and we include our units of centimeters. For the second one, we're looking for the area formula. This is 1/2 theta r squared. So we're going to take 1/2. We're going to multiply by our theta, which is pi over 4. And then we're going to multiply by 5 squared. This will give me 25 pi over 8, and it's centimeters squared for area. Going to number 4. Now, notice it has a negative radian, or a negative degree, excuse me. The negative simply means that I'm going clockwise. And you'll notice it is over 180 degrees. So it's going to place it somewhere in the second quadrant. We don't really worry too far, and we're just going to make sure we have our ray going out that way. We have our standard position now, and theta has to equal negative 215 degrees. Make sure that negative is clear. B. Now we have a positive. Positive means clockwise. It's over 270 degrees, which is right down at the bottom. So we're going to go all the way in to quadrant 4. We now have our angle, and we say theta equals 312 degrees. Radians. When we're working with radians, you'll notice I'm not quite at pi. So we start at 0, go to pi over on this side. If I'm not quite at pi, I'm going to stop somewhere in the second quadrant, draw my ray, draw my angle, and then theta has to equal 12 pi over 13. Last one, D. Once again, we're going clockwise because it's negative, and you'll notice it's not quite 2 pi. Well, negative 2 pi would be going all the way around, so we're going to stop somewhere in the first quadrant just before we get to 2 pi. And then we put our theta, and the theta is negative 19 pi over 10. This brings us now to the last part of this, and this is finding our ratios working with sine, cosine, tangent, secant, cosecant, and cotangent. Now, you will recall that when we are working on this material, we're going to have to follow this information. So we're going to be dealing with degrees, and in degrees, we know that our theta is theta prime. We know in our first quadrant, we have our answer. Then we find in the second quadrant, third, and fourth. The first step is to figure out what is the reference angle, then determine the sine of that reference angle, then figure out the quadrant, and attach the operational sign, positive or negative. So here we go. If I have a 60 degree, that is my first quadrant, and the 60 degree angle in the first quadrant for sine is root 3 over 2. Now I have that memorized. All right? You need to memorize that fact too. If it helps, possibly figure out what sine of 30 degrees and cosine of 30 degrees is. That might make it a little bit easier to work with. From that 30 degrees, then just simply shift the 2 points. So the x becomes y becomes x, and then you end up having the same thing. Right? Now cosine of a 45 degrees are the straightforward ones. These are the root 2 over 2. Tangent of 30 degrees means that I'm going to be taking my sine, which is 1/2, and dividing by my cosine, root 3 over 2. This forces me to flip the root 3 over 2 upside down. The 2's will reduce, and I end up with this 1 over root 3. But we're not allowed to have a root 3 in the denominator, so we move it to the top and write the denominator without. Therefore, this is root 3 over 3. Cosecant of 135 degrees. To find my reference angle, I'm going to take 180 in the second quadrant and subtract 135 degrees. This gives me a 45-degree angle. Cosecant is the reciprocal of sine of a 45-degree angle. And we know that sine is a 45-degree angle is root 2 over 2. So we want the reciprocal of root 2 over 2, and that's going to give me root 2. In the second quadrant, sine is positive. So my answer is simply root 2. Secant of 210 degrees. This is now in the third quadrant. To find that, we're going to take 210 and subtract 180 degrees, and we find that our reference angle is 30 degrees. Since secant is the reciprocal of cosine, and cosine is root 3 over 2 at a 30-degree angle, taking my reciprocal gives me 2 root 3 over 3. Since cosine is negative in the third quadrant, so is the secant. This brings us to the last one, the tangent of 315 degrees. So we're going to start by taking 360 minus 315 degrees, and we get a 45-degree angle. Since the 45-degree angle is in the first quadrant where we have tangent is 1, this is because we have sine and cosine equal at root 2 over 2. So root 2 over 2 divided by root 2 over 2 is simply 1. So we know the ratio is going to be a 1, and we now need to figure out what is the sign. Since it is x divided by y, and x is root 2 over 2, but y at 315 degrees below the x-axis is a negative, our answer is negative 1. Alrighty, let's just go ahead and keep going. We're going to take a look now at the opposite side, and the opposite side is giving us finding and evaluating our radian values. Now this is what we've been working on most recently. Remember that when we have a pi over 6, all we care about is the denominator. The denominator tells us where we're at. In this case, the equivalent to the 30-degree angle, and our cosine is root 3 over 2. That makes sine 1/2. In the first quadrant, sine is positive. We move on. Cosine. The denominator is a 3. Cosine has a 1/2 whenever the denominator is a 3. The question then becomes, is it a positive or a negative? In the fourth quadrant, cosine is positive. My answer is 1/2. Now, in C, there are two ways to look at this. We can either work with the even-odd identity, which we've already seen, in which case we take out the negative, calling it the negative tangent of 5 pi over 6. We then go to our tangent in terms of the 6 denominator, and that's root 3 over 3. How many 3's in 6? There are 2 of them. So we're looking at negative root 3 over 3. The other option is for us to work backward, and we go in a clockwise rotation. This is going to put me in the third quadrant, so I now know I have a negative. The reference angle is pi over 6, and I now have root 3 over 3 from that reference angle. Since I'm looking at a negative, I'm going to have a double negative, so that should have been a positive there, and it now gives me a positive. Notice the graph can make sure I make any errors, I get them cleaned up. After all, this is a positive slope. Okay. So my answer is root 3 over 3, and once again we have to be careful. We bring out the negative, but this right here is giving us a negative in the second quadrant, right up there, and a double negative makes us a positive value. The cosecant. The cosecant is the reciprocal of sine. We're looking at a 3 in the denominator. We know that sine of pi over 3 is root 3 over 2. So our reciprocal is 2 root 3 over 3, and we're looking at an angle in the third quadrant, and sine is negative in the third quadrant. Secant of 7 pi over 4. Pi over 4 is a 45-degree angle. That gives me root 2 over 2. I want the reciprocal, which will give me a positive root 2, and cosine is positive in the fourth quadrant. So my answer is positive root 2. There went my lights. Hopefully you can still see me as I'm going to keep going. Going to F. We're now looking at a cotangent in the second quadrant. Notice the pi over 4. We now know that our answer is either a positive or negative 1, and in the second quadrant, cotangent and tangent are both negative. My answer is negative 1. Number 7. We're now trying to find the Pythagorean theorem, or use the Pythagorean theorem to find the missing value. We know that x squared plus 3 squared has to equal 7 squared. So x squared has to equal 9, must be x squared plus 9 equals 49, and subtracting 9 from both sides will give me 40. I now take the square root of x squared, and I get the square root of 40. Now, I do expect you to break down that 40 into the square root of 4 times the square root of 10, which is going to give you 2 root 10. This is the answer we're looking for. Please be aware they will always be positive ratios. B. Hypotenuse is 5, so we're looking at 2 squared plus x squared equals 5 squared, or x squared plus 2 squared equals 5 squared. I get 4 plus x squared equals 25. This gives me x squared equaling 21, and I now take the square root of x squared and the square root of 21. There are no perfect squares in 21 for me to remove and simplify. So my answer is simply the square root of 21. Number 8. Number 8 is asking me to find the two solutions between 0 and 360, so we are in degree mode. Cosine will always have a 1/2 at pi over 3, so we know our reference angle theta prime is pi over 3. Cosine is negative in the second quadrant, and we would be finding our angle by taking 180 and subtracting 60 degrees, the 60 degrees. I got to remember I'm in degree mode, right, everybody? So I now subtract, and my first angle in the second quadrant is 120 degrees. Going to the third quadrant, the other place where cosine is negative, our theta 2 is going to end up being 180 plus our reference angle theta prime, and that was a 60-degree angle, so we have 180 degrees plus 60 degrees gives us 240 degrees. And this is the second solution. So we have found the two solutions in degree mode, 120 degrees in the second quadrant and 240 degrees in the third. We then go to number 9. The sine of theta is 1/2. Sine of theta being 1/2 for the reference angle has to be pi over 6. This is my first angle in the first quadrant. We also know that sine is positive in the second quadrant, and that our angle 2 has to be 180 minus our theta prime, or in radians, as we're doing it this time, it would be pi minus theta prime. Taking pi over 6 away from pi, and my second answer is 5 pi over 6. Let me just tack rad behind so I have my 2 units. And I have the two solutions between 0 and 2 pi. Now the last question that we have to do is find all 6 trig ratios. Now this question could be in radians or it could be in degrees. You have to just roll with the punches, because you never know. I might have one test with radians and one test with degrees, both with radians, both with degrees. You'll just have to do it. So I'm going to start by putting my answer in the secant position. 2 root 3 over 3. Notice my cosecant will also be negative, and I'm now going to work with the cosine. So I'm taking the reciprocal, negative root 3 over 2, and we know that we will have the same sign as the cosecant, And what pairs with root 3 over 2? 1/2 does. When I take y divided by x, I'm going to get a positive tangent, and this is going to give me root 3 over 3. I know this has to have a 60-degree reference angle, but we're sitting in the third quadrant where both sine and cosine are negative. So I filled in all of the appropriate information, and I'm now looking at it based upon the reference angle. The reference angle is a 30-degree reference angle. We are sitting in the third quadrant, so I'm going to take 180 plus the 30 degrees, and I get 210 degrees. That's the test. That's the pre-test. That's what I expect you to be able to do on Thursday. There you go. I hope this has helped you. If it has, please remember to click like. Thank you very much, Hornets. Be safe, take care, and be kind to each other. And remember, if you're struggling or having a problem, make sure you come and talk to me so that we can work it out. Bye-bye now. Be well, take care, and be safe. Cheers.